Okay, let's start. It's 5 minutes past starting time, so it's a good moment to get you going. Welcome to this webinar, which is hosted by Codemotion. My name is Jettro Coenradie. I'm from Luminous, and I'm going to tell you something about building your first recommender. If you want to meet with me, I'm at Codemotion Amsterdam, the 16th and 17th of May. There will be tracks related to machine learning and big data, which I'll probably follow as well. And be sure to check your email after the webinar, because there should be something waiting for you. Surprise. Well, this is me. I'm a fellow at Luminous. I'm mainly busy with Elasticsearch, Java, Angular, those kind of technologies. If you want to know more about me, check my LinkedIn profile, and you can visit our website. Well, that's a strange image. This is an image of a record store. I used to work here when I was going for university. I earned some money, and a record store, well, it says it all, it sells records. Well, when I was working there, it was mainly CDs, but they also had games and books and all those kind of things. When you work in a record store, you do all sorts of things with customers. You try to help them whenever possible. And sometimes it's funny because they come to the counter and they would sing or sort of sing a song. And then they would ask you if you have that song. Well, of course, first you have to think about it, what it is. And if you recognize it, then have to look it up. But that's one of the things that people would ask. Another thing is, for instance, that they say, well, I like you too, and I like Coldplay. Do you have something else that I would like? So that's already starting to feel like recommending new music to your customers. But it could also be that they buy a CD from Soundgarden, for instance, and well, we just had a new CD from Temple of the Dog, which I think if you like Soundgarden, you also like Temple of the Dog. So maybe you should buy that CD as well. Well, if that's not a recommendation, then I don't know. So a final one that I would like to mention is playing music in store. So people visiting the store, they listen to the music that you play, and well, maybe they're interested in it and they could buy it as well. But of course, there's a but. Would you recommend things that you don't have in stock? It sounds funny. If you have a recommendation for something that you think someone would really like, but you don't have it, well, of course, you could order it. So that's something that you should think about. It could also be that you advise different things in other seasons. So during Christmas, for instance, you would advise other type of albums than you would during the summer. So there's a context in what you advise or what you recommend. Another thing is personal taste. It could well be that I like certain kind of music much more than other kind of music, and I would like influence you with what I know about music and what I like, which doesn't necessarily mean that you would like it as well. But it's not what you want, of course, but it could still happen. So there's an important distinction when thinking about these kind of things between advertorials and recommendations. So let's step into that one. An advertorial is not really based on knowledge you have about you. It doesn't really have context. It's just something we would like you to buy. It's something new maybe, or something nobody knows yet. And it could be that, we'd like to persuade you to have a look at it, and maybe you like it and then you could buy it. But when we're talking about recommendations, it's much more because we know something about you. We know what you like because you bought something with us before, or maybe you told us something about yourself, and therefore we can give you a real recommendation instead of an advertorial. So let's get to a few examples. If you think about playing music in store, this is not something that we would ask you what you would like to hear. It's just something that we would play no matter which persons are in store. So it's more like an advertorial. But if we would have on the wall an album top 40, this is based on what people buy. So this is actually already, it's maybe not really about that we know something about you, but it is something about we know about the content, about the items that we sell. These are the items most people buy, so you might be interested in it as well. This is more like a recommendation. Now, a corner case. So it's Saturday morning and it's early and we are in store and we play specific kind of music. I've shown just a few albums that I know from back then that we played a lot and people would buy them. Well, I already mentioned before that playing music in store is an advertorial. But in this case, it's Saturday morning. We know what people like that come to the store at that time. So we have more context. We know more about the people that are in our store. This is actually becoming a recommendation. So this was back then. This was in the record store that, well, they're not here anymore. So not a lot of people buy music in record stores anymore. They buy them online. But this is so much different, buying music online or finding stuff online. If you look at one of the big websites in the Netherlands, bol.com, this is the main page I opened up like 2-3 hours ago. And it's not that different. I mean, there's a bulk alert like, oh, I don't know anything about you, but go here and buy the stuff that we have. And buy it cheap. This is an advertorial. There's also what we call the daily advertisement, bulk dagaanbieding. This is also an advertorial, just like the one on the top. But if you look closely in the middle, then there's stuff that it says like, this could also be interesting to you. This is because I looked at some products on their website and therefore they feel that maybe this is interesting to you. Maybe you're looking for this. So now they know something about me and then it becomes a recommendation. Let's look at Netflix. At Netflix, we all know that they track a lot of us. They know everything we look at. They know what we don't look at. They know a lot. So if you look at one of the main screens of Netflix, it starts, well, it's in Dutch, because you watched Killer Elite, then you should watch these movies or these series. Well, this is a recommendation. And one of the others, there's just a line of action movies. So this, well, it's most likely advertorial. It's just action movies. Well, not really, because if you look closely, there is one actor in almost all the movies, and this is the actor that I look at with my kids a lot because they like him. So this is also a recommendation. So you have to be careful there as well. A lot of recommendations going around, trying to trick you into doing things, buying things, watching things. But what's the goal of a recommendation? When working on recommendations, this is really important to think for yourself is, what's the goal? What do I want to achieve? Well, in case of the record store, my goal was to make people happy. I wanted them to buy the music that they really like and be happy with the music. But of course, my boss, he would like to sell as much CDs as possible. So if he has a recommendation, he wants to buy to sell more CDs, so to earn more money. Or maybe it's also trying to trick people into buying more things at the same time. But the trick already sounds negative. It could also be that we make them happier by buying more things, by recommending them the stuff that they really like. If you have set these goals, then you also want to measure whether you achieve the goals. You need a dashboard, analytics. So what kind of analytics do you need to gather to see if you meet your goals? Well, a few of the analytics that you could try are things like returning customers, because returning customers are usually happy customers. You could track the amount of money spent per visit. Because if the goal is to earn more money, then it could be wise to see if people start spending more money because we recommend better items to them. Maybe it could be not necessarily the money, but more like the number of items they bought per visit. And it would be even more interesting if we could track whether if we recommend an item, if they would actually buy that item. So there's a lot of things that you could measure and put in a dashboard for you to analyze whether your recommender and the goals you set for the recommender are actually working. There's two types of recommendations that I would like to discuss today. The first one is collaborative filtering. With collaborative filtering, you have to have a user base, and the idea is that together you decide which things are interesting, which movies are good, which CDs are good, and then based on what others tell you about certain items, you can give recommendations to users that are kind of similar and like the same things. And that way you together come to a good set of products, items that you would like and that you might be tempted to buy. Some examples. For instance, collaborative filtering you can achieve by asking users for explicit ratings. So you could do a rating by people liking something or not, or maybe even buying something or not. And then if they buy things together or like the same things together, then you could use that for a rating of that item. You could also do things like a number of stars or maybe a grade, like a lot of online shops do. Then people rate products. And with these ratings, we can try to find similar users that rated the same items in the same way. And then we can use that to give good recommendations. A problem with explicit ratings is that people tend to give higher stars or lower stars because it's cool or whatever, and it doesn't really reflect what they actually do. So if they listen to music that nobody thinks is cool, but they still like it, then they give low stars, but they listen to it a lot. So that's where implicit ratings come around, and they really look at what users do. So they could, for instance, check if someone looks at the details of an album before they give a rating, or maybe even go to YouTube to listen to it before they give a rating. And you can also track if they give different ratings, like low ratings, for items that they use multiple times. And this is what we call implicit ratings. We can create a score or a rating ourselves, and based on this rating, we have an implicit measurement of what the user thinks about an item. So that's a big difference. Another way of filtering content is based on characteristics of the content itself, or based on our own knowledge. So if you think about the music industry, for instance, what we could do is categorize albums or artists based on genres like rock or Motown or soul or jazz. And then based on that knowledge, we could feel that, hey, you already bought 2 jazz albums, maybe the third jazz album is also interesting to you. So that's another type of filtering, another type of recommendation than the ones that are user-based. So you, like I mentioned, the genre of the music, maybe similar kind of artist, so not really into the album, but in the artist that create the album. Maybe even albums of the same artist. So if you already bought 2 albums of one artist, then you might also like the third album of that same artist. Maybe a little bit lower, it's like the producer. If you already bought a few albums of one producer, then it could be that you like all the albums that that producer was involved with. And then we can have content-based recommendations, and we don't need ratings from other users to give you this recommendation. Okay, let's talk about the demo that I created. The demo doesn't do content-based recommendations. It really only does the collaborative filtering. It is about 500 albums of the Rolling Stone Top 500 that were selected over the past years. And the users of this website can rate the albums. And if you rate a few albums and we have enough users that rate the same albums, then we can create recommendations based on collaborative filtering. And that's what we're going to talk about today a bit more. Okay, so the goal of the system could be to get as much users or ratings into the system as possible, because then we can give better recommendations. And we want to use these recommendations to attract even more users. So they should become curious about the albums that they would like, and that way start listening to them. Well, this is a dashboard that I've created. It's very basic, but one of the goals was that we would have more ratings. That's what you can see in the left corner, the left top corner, and on the left lower corner you can see the number of users that are in the system. Well, as you can see, it's not a lot yet, but maybe after today it will be a bit more. So let's go into the system to see it at work. I have to switch a bit. It's in rolling 500 luminous Amsterdam, and then you get into this browser window. Well, as you can see, I already put in enough ratings to get recommendations. So I have 5 recommendations in here. You can see the title of the album, the artist of the album, and the score the album was given. This score is a prediction of the rating that I would have given this album. So let's go into the ratings. In here we see all the albums, and on the right we can give them a rating. If we would click this one, then I would say that I like this album. If I would click the middle one, I say okay, it's okay. And this one would say I don't like it, and if I made a mistake I can push here and then the rating is gone. And then you can go through the complete list, and then if you fill out this list and you go back to home, then you would see the actual recommendations again. And if you want to see the dashboard, you can click in the top left and then go to the dashboard. Well, that's it. So let's continue. So how do we get to this recommendation? First, we have to obtain all the rating data. Just like we saw on the website, we have to enable users or visitors to select items and make them, well, mark them as favorite or not, and then we have to store it. If we have all this data, we want to rank other users and compare them to you and find the similarity, well, find the similar users, so with a high similarity to you. If we found a number of similar users, that's what we call the neighborhood. The neighborhood are those users that are similar to you, which is in this case, for instance, the top n similar users. And then based on this neighborhood, those similar users, we can predict ratings for items you didn't rate yet, but users in your neighborhood did. And then when we found these items that you didn't rate yet, and we could give a prediction, and then the highest predictions we present as the top rated items for you as recommended items. So the first step in making it possible is create a user item matrix. User item matrix looks like this. In this case, I made it easier by selecting the artists and not necessarily the albums. As you can see, we have 4 users, Chris, Mabel, Jack, and Angela, and the green numbers are the actual ratings that they've given. 3 means the green face with yes, this is really good. 1 means the red face with I don't really like this, and 2 is I'm okay with this album. Now, when comparing users, we would take all their ratings that they've given for all the albums that they rated, and then compare them to the other users. And if they're similar, then, well, then we have found a similar user. Of course, we're going into how you do that later on. The other way of looking at it would be in the vertical way is check an album and check all the ratings and then find albums that were rated the same way. That is another way of looking at your data. And that's actually the 2 ways that you can always do. So this image, you can see if you start in the top left corner with user I, then if a user I rates an item, so you go to the bottom, then you have an item and you can find similar items to that item. That is what we call item-based recommendation. But if you go from the top left corner to the top right to the user J, then you find a similar user first, and then if you found similar users, you check the items that users have rated, and then you find your recommended items. In this case, then you found a user-based way. So first find similar users and then check the items they've rated. In the other situation that we talked about, the item-based recommendation, you first check your own items and then you find similar items to the ones you already rated. Well, these two approaches, what you usually do is if your user base is much bigger than your items, then you would choose the item route. And if it's the other way, so if you have much more items than users, then you would do the user-based similarity. Let's discuss how we can calculate the similarity between users or items. The way to do this is by using a similarity algorithm. The concept of similarity is like this. So if you have a similarity function, then you provide it with two users in this case. If I would provide it with the same user, so user I 2 times, then the similarity would produce 1. In the complete opposite way, if I would provide one user and another user which is totally different, then the similarity would become 0. That's the whole concept behind similarity functions. There's a lot of similarity functions out there. A few of them are here. The checkered distance, for instance, which is used to compare items in a Boolean way, like bought or not bought, liked or not liked. Then we have the L1 and the L2 norm, who provides ratings. We will have a better look at it later on. And finally, we have the cosine, which compares vectors and the angle between vectors, and we have a much better look at that one after this. So let's look at the L1 norm first. On the left side, we see a matrix with two albums as columns, and the rows are the users. Then, if we have just two items, album 1 and album 2, we can put them in a chart and we can plot the users in this chart. So if you check the red cross, it says for album 1 it has rating 2, and for album 2 it has rating 1. This is the user 3, so it's the third row in the matrix. If we take the green mark, which is user 1, we see that it has given a 1 to album 1 on the horizontal axis and a 3 to album 2 in the vertical axis. Now, to determine whether these users are similar or not, we calculate their distance. And with L1 norm, we calculate the distance in a horizontal way as well as a vertical way, and then we average out the differences. If we calculate the formula at the bottom, we have calculated the similarity between the two items. As you can imagine, if they are almost on top of each other, the number becomes low, and the further they are apart, the number becomes higher. There was an optimization in the L2 norm where we would not take the horizontal and the vertical distance, but we would take the bird's eye view distance. It's another way of measuring the distance between the points. Whether it's better or not is something that you have to figure out with your own data. It's not something that is something you can state beforehand. It's something you really have to try. But in general, the L1, L2 norms are not that good if you have a lot of items, because the deviations between the items tend to increase the moment people rate more items the same. So it would become negative if you have a lot in common in the items that you rate, but there is differences. So it's better to look at vectors, in that case the cosine similarity. So let's have a look at that one. We have the same matrix again. And now, instead of looking at horizontal or vertical or bird's eye view length, we look at vectors. So we see the same type of image, again, album 1 and album 2 on the horizontal and vertical axis, but now we've drawn vectors for the three users. And to determine the similarity between the users, we're going to use the angle between these vectors. So if you look at the angles between the user 2, which is blue, and user 3, which is red, this is larger than the angle between user 1 and 2, the green and the blue one. So this would mean, based on the cosine similarity, that the green one and the blue ones are more similar. So let's have a look at the formula that comes with this. This is already a bit more complicated, but it's not that hard yet. The similarity function is, if you would work it out in a calculus way, it would look like this, but it's easy to implement this way. And you can even do it by hand. So if we take the matrix on the left and all the figures on the right, let's go through it once because it's interesting to see in the next figures as well. Let's first take the red circle. This is the rating the user 1 has given to album 1, which is in the formula on the top as well as the bottom for where we iterate over the albums and over the users as well. So if you follow along with the colors, it should be easy to find where to put the dots. And of course, in this simple example, it feels almost too obvious to use. But the moment that you start comparing more albums, then it's not easy to draw anymore, but the formula still holds. So you can still use this similarity function. There was, though, one problem with this approach, is that you have users who tend to rate higher than other users. So especially when you move into ratings that are more diverse than 1 to 3, but maybe go from 1 to 10, then you have users who tend to give 10s to everything they like, but you also have users who tend to give 8 to what they like. So what we do is we normalize the results by taking the average of the ratings a user has given. And this is what is included in the right column, the blue one, where we have calculated the averages of the ratings a user has given. And if you look at the formula, where we now subtracted the average rating from all the ratings. This is what we do with the normalization. There is one interesting thing though. If you would do this for the scenario that we have uphand in the matrix, and you would calculate it, the result would be 1. Which is interesting because that would mean that the users were exactly the same. And if we look at the ratings given, that's not the case. So you always have to be careful when you look at these kind of calculations that it is an approach. But it is an estimated approach. It's of course not exact. So it could well be that, due to the similarity function, two users are exactly the same. But if you go through all the ratings, then you would see that there are some differences. Okay, let's move on to the neighborhood. I already mentioned it before, that the neighborhood is actually a group of users that are similar to you. And based on this group of users, you could do predictions to the ratings you would give to items, to albums in our case. What we could do is calculate all the similarities between you and the different users, and then use something like a threshold, some sort of factor to determine when we say that users are similar to you. You could, for instance, say that the similarity should be at least 0.5 before we say that a user is similar. Based on the amount of users that we have in our system, that will be a problem because we don't have a lot of similar users then. And it's actually quite low in my example. But the more users you get, then you could increase this threshold and limit the amount of users that are similar to you, and all the users that you would have in your neighborhood then are more similar, so they should give you better recommendations. This is also the area where machine learning could help you out. One of the machine learning algorithms like k-means could help you out to cluster users before you start the actual similarity check. So what you then could do is, if you have a lot of users, you could first cluster them to find your first step neighbors, and then only do the similarity calculations based on that first subdivision of your users. So how does k-means work? K-means works with a number of clusters. So for instance, this could be, in this example, I would create 3 clusters of users, and I would just randomly put them somewhere in space, in the vector space. And then for each point, I would calculate the shortest distance to the centroids. And The shortest distance is the one that I would say, like, okay, for the dot, the cross that I've stated with the 3 arrows, I would say this one is closest to the green center. So from now on, it's in that cluster. If you would do that for all the points, then you could get something like this. So now all the points are connected to one of the 3 clusters. Then the next step would be to move the centroid of the cluster to the actual center of that cluster, and then we would start all over again. It could happen that if you move the center point, that one of the dots, one of the users in this chart, then suddenly becomes closer to one of the other centers, and then you would move it. And you would keep on doing this process, like finding the closest centroid, create the clusters, move the centroid, and then start all over again until no users move from one cluster to the other anymore. And then you would have your clusters that you could use as input to your similarity algorithm. So now we found all these users that are similar to me, and how would we predict the rating for a certain item? Imagine user X has 5 users in his neighborhood, user 1 to 5, and we want to find or predict the actual the classification, we want to predict the rating the user would give. If we would do this the classification way, we would calculate or count the amount of times a certain rating was given. So the rating 1 was given once, the rating 2 was given once, and the rating 3 was given 3 times. In this case, we would say that we would predict you as a user to also give 3 rating to this item. Another way is the regression way. This is more calculating the rating you would give. In this case, I would take all the users, take their ratings and average them out, and then the rating you would give, we predict, would be 2.4. Okay, let's move on to the implementation of the example. This is the way I've created the example. The front end is built with Angular, the back end is built with Spring Boot. There is a small wrapper to talk to Elasticsearch, and all the data is stored in Elasticsearch. Then there is a library called LensKit that I use to calculate or determine the recommendations. So how does this work? A user enters the website. First, an object is created in the data store, but we cannot make recommendations yet because we don't know anything about the user. So the user starts rating items. The ratings are stored in the database, and when we have enough ratings in the database to find similar users, we would gather evidence. We would gather recommendations, but what we also do is we would gather evidence. And evidence is something that I will explain a little bit later on what we mean with evidence. So when we have all the ratings, we can ask for recommendations to the LensKit library. LensKit then gathers data from the data store. It creates the user album matrix that we discussed before. It then uses the Cosine Similarity to find similar users, and when it found similar users, it will do the rating predictions. LensKit is a library which is open source, and you can find it at this URL. I would urge you to have a look at it if you like this kind of technologies, because it's very low level to start. You don't need a lot of hardware to start experimenting with it, and it's fun to do. So how does it work? In the database, in Elasticsearch, we have a user index. In this index, each user has an ID, and it stores the ratings as an array of integers. Because we know we have exactly 500 albums, this array can be exactly 500 length, and we know on each location, because the order is fixed, which rating belongs to which item. This is a very efficient way of storing it in a document store. But the problem is that LensKit cannot use it this way. LensKit needs to have a list of rating objects. So we have to create that. But Another thing with LensKit is that it uses longs as identification, and our users have strings. So each user ID is a string and not a long. So we have to map for each time we do a recommendation run, we have to map the string to a long to later on identify the users. And this rating object now has 3 fields, 2 longs, one for the item ID, one for the user ID, and it has a double, which is indicating the value of the rating. Some code. This is done in Java. The first part is configure LensKit itself. In line 2, we create a configuration object. Then in line 3, we say that we're going to use a user item scorer. This means that we're going to compare users to other users. In line 6 and 7, we also add something to do the normalization that we discussed before. So to use the average of users and to normalize all their scoring values. And then in line 9 and line 10, we configure the threshold. So in here you can say the value for similarity, and you can make it higher or lower. If you have a lot of users, you could make it higher because chances that you will find similar users are then bigger. And then in line 15 and 16 is where we would actually attach the Cosine Similarity function to LensKit. And line 12 and 13 are also for the normalization. Then in line 18, the final line, we see the data access object, which in our case is a very basic one. We obtain all the objects from Elasticsearch and just put them in a list, so it's an in-memory representation. The moment that you get more users, this will probably be a problem. And then there's lots of other ways you could do data access, like in sliding windows and those kind of things. And then in the next step, we are going to initialize the recommender itself. In line 4 and 5, we create the recommender and we use the configuration object that we created in the previous slide. Then in line 7, we get the item recommender because we want to recommend items based on the items that you found already as recommended as rated items of the user. And then in line 9 and 10, we provide the user we want to have recommendations for. And the num recommendations parameter just tells it how much recommendations to return. And then in line 12 to 15, we just do a little bit of Java magic to map the LensKit object score ID to the one that we want to send back to the client. Well, that's it. That's everything you need to do in Java to get recommendations. Then there's one other thing that I also would like to mention, which is called users and items. Which are users that don't have ratings yet. I think we discussed them before. These are just new to our website. So what can we do to give them recommendations as well? Well, of course, the easiest thing to do is get information from them. Well, ask them to rate a few items, and if they've rated a few items, then it becomes easier. Then we know them, and then we can probably give them some recommendations. Another approach could be to just provide them the top selling items as recommended items. Then at least you can give them a few recommendations, but yeah, how good they are is hard to imagine. And then for items, we also can have cold items. These are new items. Well, in our scenario, this is a bit hard because we have 500 fixed items, but it could also be that we have items that nobody rated yet. So what you could then do is randomly ask people to rate specific items and just ask them for a rating. What we could also do is, if you are more into the Bol.com or the Netflix approach, is to just give a list of new items that nobody has seen before. And there's always users who would like to try out new things. So you could get ratings that way. And the final approach is to combine it with content or knowledge-based recommendations. So if someone recommends or just rates one of the items, which is a jazz CD, you could maybe provide them with a few recommended other jazz CDs as well, and hope that they will listen to them and rate them as well. Well, that's it. If you want to try it out yourself, the top URL is where the application is running live, and the bottom URL is on GitHub, where the code is if you want to try it out yourself. Like I mentioned before, I'm at Codemotion. I will do another talk on relevant search results, which is the 17th of May. And don't forget to check your email. I will now check if you had questions and answer them. Chat, polls, questions. I don't see any questions. So if there's no questions now, then I think we can call this a wrap. And I would like to thank you for being here and listening to me. And I hope you liked it. And if you have other questions, there's enough ways to contact me. So have a pleasant evening and goodbye.